Hello and welcome to part 4 of Project Liberty Lite, where we will perform some audio integration into our system. The only thing that we're updating here for this part of the series is that we're adding this DFPlayer Pro Mini MP3 player and a couple of speakers to our system, and also a couple of capacitors here that I know that it's hard to see at this angle, but later in the video I'll try to get some close-ups, and then I'll do a little bit more explanation on the connections. But for this part, all we're trying to do is add audio to the system so we can eventually play some music and maybe some other audio files specifically for what we're trying to do for Project Liberty Lite, and that is to create kind of a patriotic display, displaying the American flag on the LED matrices, and we'll try to figure out what else we can do as we progress. So as I've said, what we're doing in this part is we're just adding this DFPlayer Pro Mini MP3 player module to our circuit, and then all the connections that are required to come to and from this MP3 module board, going to the Arduino and to power, and then also the connections needed to go to these two speakers I have here. These are a couple of, I believe they're 8 ohm 3-watt speakers that I'm using here. They're the same speakers that were used, or the same type of speakers that were used for the Albot project series. And the code is pretty much exactly the same as it was for the Albot project series that we're using here for Project Liberty Lite. Speaking of the code is exactly the same as it was before, except for the addition of what little code that we need to be able to run this MP3 player module and run, for right now, just a single audio file. And what we're going to do in this video is just add a single MP3 file that will play the Star Spangled Banner or the United States National Anthem, and everything else will be running the same. So it's going to display the American flag. We'll still have the ability to change colors on the matrices, the red, white, and blue, and then also display the American flag on the matrices. So as you can tell, I've already set up everything. I didn't really want to go through an exhaustive explanation on exactly what all the connections are here. I've left a link in the description of this video for a step-by-step process on how to do that. And like I mentioned earlier, we used this exact same type of MP3 module in the Albot series, and specifically it was part 2 of the series where we added an MP3 player module to that system, and the process is exactly the same. Like I just mentioned, I'll leave links in the description of this video that you can go check out, either that video for the Albot series where we did pretty much the same exact connections to this type of MP3 module, or you can check out the article for part 4 of Project Liberty Lite, where I go in complete detail on how to do the connections, and also the code that was added to our code that we left off in part 2 of this series, because part 3 we didn't add anything to the code. So the only thing that's been updated to our code is for the MP3 player module, where we need to install the DF robot library and just basically add a little bit of code for setup, and then also for playing the MP3 file that we're using for this particular part of the series. So again, I'll leave all that information down in the description of this video, where you can find all the information that you need on how to set that up. But I may mention a few things here and there in this video as we move on. There is something that I do want to mention here. I mentioned earlier that there's these capacitors that have been added to the circuit, and in the article, I believe, the original setup, these capacitors were not there, but later there's an explanation on why or why I added these capacitors. There was a part in doing the connections for the MP3 player module and the particular setup that we have here for Project Liberty Lite that I was having some audio issues where when I had the volume set on as high as it can go, that the music would play loudly, and then within a few seconds, the audio would cut out. At the moment of audio cutting out, the speakers would make a pop sound. The music would stop. The LEDs would also flicker when the music was playing, but once the music stopped or cut out, the LEDs would be just fine and everything would look normal. It's just the audio would cut out. And that was due to a brownout in the circuit. And I'm not going to explain exactly what was going on just right here, but I will add a video clip of that issue because I created a separate video on what was going on and then walking through the steps on what I did to alleviate that issue. And again, I'm not going to discuss it right now. I will add it at the end of this video, most likely. And that way you can see it here. So let me give you a more close-up view of what everything looks like. I may discuss on some of the connections, and then we'll get to demonstrating it. Okay, I got you a little bit closer, and I did the best I can to get a decent view to kind of show you a little bit of what's going on and what's been added to our system. Like I said, we're adding this MP3 player module. It's a DFPlayer Pro Mini MP3 player module. And if I need to put my mic down so I can use both my hands. So hopefully you can hear me fine. So I placed the MP3 player module on the breadboard. The view that we're looking at it right now is that it's in an what I would consider an upside down position, where the USB connection is here at the bottom. So the pins, I know you can't see it in the camera, but the pin labeling on each side of the board are currently upside down. But these connections here on this side are the connections to the two speakers back here. So we have the R minus, R plus, L minus, and L plus connections. If I can turn that, that's the R minus, R plus, L plus connections. So that's the negative and positive connections for the right speaker, and the negative and positive connections for the left speaker. So all I did was take I'm using the yellow jumper wires as my negatives and the orange jumper wires as my positives, and the yellows are connected to the black wires of the speakers, and the orange jumpers are connected to the red wires of the speakers. So those are my speaker connections to and from the MP3 player module. And these connections over here, I have these blue and orange jumper wires here, and they're connected to the RX and TX pins of the MP3 player module. The blue jumper wire goes over to pin 4 of the Arduino, and the orange jumper wire comes from the TX pin of the module, and it goes to pin 5 of the Arduino. And pins 4 and 5 of the Arduino I've set up in code to be the TX and the RX pins. So I'm taking the blue jumper wire coming from the RX pin of the MP3 player module, going to pin 4 of the Arduino, and in code I've set pin 4 of the Arduino to be the TX pin, and this orange jumper wire comes from the TX pin of the MP3 player module and goes to pin 5 of the Arduino, and I've set pin 5 to be the RX pin in code for the Arduino. And like I said, there's an explanation of what we're doing here and of the code on the article for part 4 of Project Liberty Lite at the website, and I've left that link to that in the description of this video. These two other connections here, where this white and yellow jumper wire are the connections to the VN pin and the ground pin. So that's for our power to the MP3 player module. I've used the yellow wire to go from the VN pin over to a point on the breadboard that's in line with the legs of both this 1000 microfarad capacitor and this 0.1 microfarad capacitor. They're both in parallel, and the capacitors are also in parallel with the power connections to the module and from the power connections to the power rails of the breadboard. So that yellow connection from the VN pin to a point on the breadboard is in line with the anode leg of this electrolytic capacitor. That's the 1000 microfarad capacitor, and it's in line with one of the legs of the 0.1 microfarad ceramic capacitor on the board. I know it's kind of hard to see, but again, I've left a complete description and also imagery of these connections at the article for part 4 of Project Liberty Lite at the link in the description of this video, so you can get a better look and idea of what's going on here. So from that connection, there's a red jumper wire coming from a point on the breadboard to a point on the positive power rail that we've set up on our breadboard here. And then this white jumper wire comes from the ground pin of the MP3 player module to a point on the breadboard that's in line with the cathode leg of this 1000 microfarad capacitor and to the other leg of that 0.1 microfarad ceramic capacitor. And in line with those connections is this black jumper wire that goes to a point on the negative power rail that we established on the breadboard in the previous parts of this build series. So that's pretty much the connections. And again, there's an explanation of the code and how to set up the code and everything for the DFPlayer Pro Mini MP3 player. And I've also gone over in that article on how to add your audio file to the MP3 player module. All that information is in that article for part 4 of Project Liberty Lite. Again, you can find all of the information that you need to set up your circuit from the links in the description of this video. I know I didn't explain it very well, I know I didn't explain anything very well in this video. I just kind of wanted to show you a visual of what's going on and just update you on what's going on in the circuitry here without going through an exhaustive explanation. But you can find detailed explanations on how to set up your DFPlayer Pro Mini MP3 player on the breadboard and the connections that you need to make, and how to add your files to the board, and also how to import the libraries for the board and add the code that's necessary to be able to use the board with our project that we've been developing throughout the rest of this series. So next I'm just going to show you a quick clip on the circuitry operating, and then we'll wrap up this video. So let's go ahead and see what our system does now that we've updated it to play audio. Okay, I'm gonna power this right now from the AC power adapter that we set up in part 3 of this series. And I'm gonna turn it on from the switch here, and then we can see how our system performs now with our updated audio that we have. So I'm going to turn the switch on now, let it power up. And I'm going to turn it off because it's kind of early in the morning in my household right now, and I don't want to wake anybody up. But as you can tell, that now when we turn the switch on and power the system, the LED matrices come on and the music plays, and we still have the functionality, even though I didn't demonstrate it in this video. We still have the ability to change the colors on the LED matrices, red, white, blue, off, and then also display the American flag by using our flag button, which is this blue push button here. So now at this point, we've taken another step further in adding to our system and making our Project Liberty Light that much more immersive in displaying the LED lights on the matrices, like I said, where we can display colors or shapes, in our case, the American flag, and then also play audio. And for this particular testing that we did, playing the American National Anthem or Star Spangled Banner. So in the next part of this series, since now that we have audio playback now successfully integrated into our project, we'll want to continue building on the foundation by exploring adding additional audio tracks and also organizing our audio files for easier management. We'll want to create dedicated playback modes, implement volume control. We'll want to add audio on and off functionality by maybe adding another button control in here. And we'll want to prepare the project for future synchronized animations and effects instead of just displaying colors and a single image of the American flag. We want to be able to add much more to the system that we have accomplished so far. I don't know about you, but I'm having a lot of fun working with these modules and working with the Arduino Uno and learning a little bit more about how to set up these types of modules and create things that are interesting and hopefully interesting to others like yourself. I want to thank you for joining me for this part of the series. I hope you continue forward with me in creating something very special with this Project Liberty Light. Until next time, keep at it and stay motivated. Okay, I'm going to upload the code for the volume setting on 30. I'm uploading the code now. And I don't know if you heard it in the camera, but there was a little pop in the speakers, and now the sound is off. It cut off in the middle of the song. So next what I'm going to do is I'm going to try to reduce the volume level or the volume level value down to 10, and then we'll see if that fixes that issue temporarily. Okay, I've set the value for 10. I'm going to upload the code to the Arduino now. It's currently compiling and uploading. Okay, we can notice that the sound is lower. It has not shut off yet. It's going as it should be, it seems. And I also noticed that the LEDs are not flickering like they were before when it was set completely on max value at 30. So again, this is the value 10. Okay, what I'm going to do now is I'm going to add a couple of capacitors across the terminals of the VN and ground off the MP3 player. So I'm going to remove the jumper wires I had placed before for the VN. I'm going to remove them. That's the red jumper to the VN and the positive of the power rail positive, and I removed the black jumper wire that went to ground and the negative power rail of the breadboard. Because I don't have any room next to these two pins here on the breadboard, and there's not really anywhere I can move it to create more room, or there's not anywhere I can really move the MP3 player to make more room. I'm just going to use a couple of these short jumper wires, a white one and a yellow one. I'm going to use the white one to connect from the ground pin of the MP3 player, and I'm just going to choose some location off to the side here on the breadboard, and I'm going to take the yellow jumper wire and connect from the VN pin of the MP3 player, and again just choose some point on the breadboard near that other jumper wire, the white one. I'm going to take, this is a 470 microfarad electrolytic capacitor, and I'm going to place it across those two jumper wires I just placed, making sure that I have the correct orientation for this capacitor because it is polarized. And then I'm going to take this 0.1 microfarad ceramic capacitor and place it in parallel with that other capacitor right there. I think those are in. And now I'm going to replace the red and black jumper wires I had. So I'm taking the red jumper wire and placing it in line with that yellow jumper wire and one leg of each of the two capacitors into the positive power rail. And I'm taking the black jumper wire and placing it in line with the white jumper wire and the opposite legs of those two capacitors to the negative rail of the breadboard. So now I'm going to upload the code with the 30 value for the volume. I guess we can test the 10 value first and see what that's like first before I change it to the highest value setting. So I just plugged the Arduino back into the computer. This is the volume at 10. So it sounds good. Everything's working as it should. So what I'm doing now is I'm changing the set volume value from 10 to 30 in the code. I'm now compiling and uploading the code in the computer, and then we'll have that code upload to the Arduino and see what happens. And we still have the same issue. Okay, I guess what I'm going to do now is I'm going to try to replace this 470 microfarad electrolytic capacitor, and I'm going to replace it with a 1000 microfarad electrolytic capacitor. I got to make some room here, making sure I have the correct polarity, and I'm going to reset the Arduino. Still the same issue. Since that didn't fix the issue, the only thing that I'm thinking about right now is currently we're powering the Arduino through the USB cable that goes to the computer, and maybe if I unplug this and we power directly from the female DC power jack adapter here, that we can plug in our AC adapter from the wall. Maybe that will help in the powering issue for everything that's here, because we're just taking the voltage that comes into the board from the USB cable, and there's a regulator on the Arduino board that provides the 5 volts at the 5 volt pin currently to the breadboard. And ideally we don't want to run, things like an LED matrix or 2 of these LED matrices and the speakers and MP3 player and all that directly from the Arduino itself. So let's try using the AC adapter that we provided to our system here back in part 3 of this series. And what I'm going to do is I'm just going to unplug that USB adapter. Everything's still set up as it was. The volume's still set up at 30. And let's see what happens here. And I've still got the 1000 microfarad capacitor here and the 0.1 microfarad ceramic capacitor. So I'm going to turn the circuit on. Okay, so I didn't have any issues just then. That's the farthest I've ever gotten on that song with the volume set at 30 and with or without the capacitors in the circuit. So I think that had to be most likely the issue, is that the power we were using was coming from the Arduino itself when it was connected to the computer from the USB cable, and we were getting this sort of brownouts in the audio, and the audio would shut out, but everything else was still running since we were still connected to power. And since we can sufficiently power the entire system with the power adapter, that seems to provide sufficient power to the entire circuit. So I guess for testing purposes, what we're going to have to do now is just set the volume anywhere between 10 and 20 for now. As we're powering the circuit through the USB cable from the computer to the Arduino. Again, we'll just do that for testing purposes, but ideally we'd want to be able to increase the volume as loud as we can get it if we want to have the audio that we put on our MP3 player to be louder. We want to have that choice to kind of go through the full range of volumes without having to worry about brownouts in the entire system. So for now, during the prototype process, we'll just leave the volume set at around anywhere between 10 and 20. I might just set mine at 20 for now, so it's loud enough to at least hear in the camera, and then we can continue on with the build process. And then again, we'll kind of address the issue of the brownouts from the power source when we're done with using the USB cable coming from the computer, and we're only powering the entire system with the power adapter. And that's later on near and at the final product of what we're making here for Project Liberty Lite.